right, so now that we've learned how light reflects and refracts off mirrors and lenses, we're going to look at how light can create the different colors that we see. So this is Learning Target 37. Apply how light colors can be mixed to create different colors of light. So we see this all the time. Light comes in as white light. We put it through some material. This example is a prism made of glass. And it can cause the white light to bend into all the different colors of a light spectrum. So I'm going to show you how that works. So our essential question is, how does light create different colors? So when we see visible light that comes from the sun, it looks white, but it is made up of all the different colors: red, orange, yellow, green, blue. They took away indigo, so we need to fix that. Violet. So it used to be, I would remember, as Roy G. Biv. Now it's just Roy G. Biv. Okay? It's ordered by decreasing wavelength. Okay? So red has the largest wavelength, violet has the smallest wavelength. So if we come to this question, why are some objects white? They are white because here's your spectrum coming in. It's going to hit the object, and it reflects all light. So if it reflects all colors of the spectrum, then it's going to look white. White objects reflect all light. So now let's look at black objects. Black objects, if you notice from the picture, do not reflect any light. So that's why they appear black. They absorb all light colors. So when you think about what you're seeing, if you see something as white, then that means that that object is reflecting all the frequency and wavelengths of the Roy G. Biv spectrum. So it looks like white. If you see something as black, that means it is absorbing all those frequencies, and so you see no light. So for objects' colors, object absorbs some of the light and reflects the light you see unless it's black. So if an object looks blue, it reflects blue light and absorbs all other colors. For example, the light coming in is going to hit the blue jeans. It absorbs all other colors except for blue. The blue light is reflected, so your eye sees the jeans as being blue. So jeans reflect blue light and absorb all other colors of light. So matter, remember, either absorbs or reflects light. So we've got three different classifications. You've seen this before when we've talked about how matter absorbs light. If matter is opaque, that means that matter absorbs all light waves. So it absorbs all the colors of the light, and light will not go through and you see black. If an object is translucent, an object will absorb nearly all light waves but let a few light waves through. If an object is transparent, then that means the matter will allow all light waves to pass through, and that's why you can see through that matter, because all the light waves are going through it and they're not reflecting any back. So let's take a look at an example. Okay, so if we take a look at this curtain that is not allowing any light through so that the young girl can sleep, we would say that curtain, that matter, is opaque. It absorbs all light. Now a sheer curtain, they're going to say, is translucent because it lets some light through. Some of the light is shining through on the girl, but not all. And a window is transparent. That matter lets all light waves through, wakes the girl up. So that's how matter can absorb different light frequencies. Okay, so now let's get into how light is going to create different colors. So just like in pigments and art, you have what's called primary light colors. Light can be made by mixing different amounts of primary colors. Now the primary light colors are red, blue, and green, whereas the primary pigment colors are red, blue, and yellow. So it's a little bit different. White light can be made by overlapping red, blue, and green. So take a look at this light spectrum. This is showing you what different colors can be made. You've got your primary, blue, red, and green. Where they intersect, where the primary colors intersect, that's making secondary light colors. So if you want yellow light to shine, you would intersect red and green light. They do this with stage lighting all the time. If you have stage lights, they're usually red, green, and blue. You intersect them and you can create different lights. If you intersect all three, you've got white light in the center. Red and green makes yellow. Blue and green make a pretty turquoise color that we call cyan. Blue and red make this pretty purpley pink color called magenta. So let's take a look at this example. What if the light shining on the object is not white? Then it's a certain color. So we're going to tap and see what happens. If we have white light going through and it goes through a yellow screen, it's only going to let yellow through. So that purple object or that magenta object does not look yellow. Remember, purple or the magenta is made up of red and blue light. But if you notice, none of the red light or the blue light got through, only yellow. So that's why that dinosaur looks kind of black, because it's not going to reflect the right color. So now let's look down here. Okay, remember, red, green, and blue are the primary colors. So if this screen only lets green light through, it's going to block the red light. So the apple shouldn't appear red. It should appear black as well. So now let's look down here at a blue screen. It's only going to let blue light through. So that green tennis ball, green is a primary color or primary light color, it's also going to appear kind of a black too. Now remember, if these screens had been white, they would have let all wavelengths of color through. The objects would have appeared exactly how they were supposed to. But if you put a screen up that only lets a certain frequency of colors through, then they're going to distort the color that you see. So if this screen hadn't been here and that light bulb had shined on the purple dinosaur, you would have seen a purple dinosaur. So again, let's take a look at our secondary light colors, the cyan, yellow, and magenta. Okay, so just like I was telling you about the theater spotlights, okay, so if you add blue and green, I know it sounds weird, but that's going to create yellow. Why didn't it go? I'm sorry, blue and green make cyan. That's why it didn't go, or turquoise. It should shine. Oh, it's not going to shine. I have another one that I'll show you. Okay, blue and red make that magenta color. Red and green that make the yellow. Okay, and then if you want to make white with those primary light colors, you add all three of them together. Thought I was going to show you. Okay, now this animation is located on the review for Target 37, so you can actually do this as well. So what I've got here is our three primary light colors. So I can use this scale to add what colors I want. So he's got green light, so you're going to see green. So now let's start adding some blue. Remember, red or green and blue make cyan. So if I just add a little bit of blue, it changes that color. That's how you get the shading for different colors. If I add equal amounts of blue and green, then I get that pretty cyan color. If I start taking some of the green away, I go more toward a blue color. Okay, so let's look at Let's look at red and blue. So we're going to put the red up. Let's go all the way up. Okay. Now let's add all the blue. Red and blue, remember, make that magenta color. If I start taking away the blue, notice what happens. You start to get more of a pinky color instead of the purpley pink. If I take most of the blue out, you get that a darker red, more of a orangey red. Okay, so now let's take all the blue out. Let's do red and green. Remember, red, I gotta get rid of all the blue. Okay, red and green make yellow. Okay, if I take away some of the green, get more of an orange color. Okay, if I take some of the red away, you get more of a yellow color, yellowy green color. So you can play around with this and see how the three primary colors are going to give you different shades of light color. Okay, the last thing I want to talk about is your pigment color. Your pigment color is basically you're mixing pigment colors that are different from light colors. Pigment absorbs light and reflects light. So yellow pigment absorbs blue light and reflects red and green, because remember the red and green light that's reflected will turn yellow. So that's how pigment and clothes work. Okay, they're going to absorb whatever combination will give them the color. They'll absorb and reflect whatever combination you see. So if you have a yellow shirt, it's going to absorb the blue light, reflect red and green. Okay, so let's see how that works. So just like in the example with the jeans, it's going to reflect blue light because it might, pigment will only show the let blue light through. But if you have, let's say, a yellow shirt, it might reflect the red and green light to make the yellow. Okay, so hopefully you now have a better understanding how light colors can be mixed to create different shades of colors. You're going to get a lot of practice with mixing your primary colors and seeing what secondary colors are produced. You'll also get some practice with how blocking certain colors will create different colors. So you're going to get a lot of practice with how matter can reflect and absorb different colors and what that can be created, what you're going to start to see. So that was target 37. Apply how light colors can be mixed to create different colors.